Hello, I'm Atul Rajesh with Fuad Zamari and George Thomas, and we did our final project on movie datasets. So our initial question was, what if, so we essentially wanted to arrange movies so that it would be easier to access for people. So we just wanted to figure out what the best way of arranging movies by genre and recommendation would be. Um, so our goals when we started working on this project was to extract the title, genre, and the average rating of the movies from an IMDb file. So we took the IMDb CSV file for movie ratings and um, essentially mapped it into a graph, and we were able to represent it as a proper data set from the graph. And we were able to produce algorithms that would be able to traverse and display data in different ways so that it would be better utilized for different uses, I guess. So our accomplishments as we went through doing the project was we were able to complete a full data set run eventually, and we were able to complete our BFS iterator runs, and we were able to implement a Crystal algorithm and Digistrica algorithm that was able to create a maximum spanning tree, because the way our weighted edges worked was the more weighted edges were more favorable than the least weighted edges. As for our methodology, we used a disjoint set and a graph as our graph data structures, and we used the graph as the major kind of storage data structure, and it would be initialized at the very beginning of whenever we start running our program. Then we use the Crystal algorithm later on to kind of sort out each of the movies based on their genres and how similar each of the genres were. And the Digistrica algorithm essentially recommends you movies based on a movie that you pick. So yeah. Now the disjoint set we used essentially for the Crystal algorithm to figure out if we had any cycles in our system and to figure out if we were not producing a minimum spanning tree, essentially. So the disjoint set, it felt like it was the easiest way to implement, a cycle detection system, and that's why we did that. The graph that we implemented was basically, it worked off of an adjacency matrix, and the adjacency matrix essentially held the weighted edges as well. We will talk about it more when we actually talk about our data set, but the graph was our major storage system.
Hi, okay, so the two algorithms we used besides our BFS traversal of our graph was Kruskal's algorithm and Jigsawer's algorithm. So what we used Kruskal's algorithm for was basically we had all these movies from the CSV file, and we had each of them, they had their own different ratings, names, genres. And what we wanted to do in our first step was basically arrange all the movies by genre. So each section would basically so each node in the graph would be connected to another node that shared the same genre. And what we used our Jigsawer's algorithm for was basically we would start at one node or one movie that a user would put in, and we would find the max distance to another node that was possible. And what we would do is then we would go through each node in that path and basically find the minimum weighted distance. So you find the closest movies in terms of genre to the previous movie, and then you would keep traversing and then keep adding those movies to the path until you get all the way to the max distance node. So that way you can have a max number of recommendations that a user would want.
So there were three main challenges that we faced when trying to answer our leading question and achieve the goals that we set out for our project. And those three main problems were that we first had problem accessing the JSON files for the movie metadata, as we got different files. And the other problem was when we created the max heap and then had to drop it, and when we implemented the breadth first search with the disconnected graph. So the first problem was the JSON problem. JSON files with metadata for the movies, which had the ratings, the genre, and the title of the movie, these were files we got online. And so they were initially JSON files which had commas in them, and this was incredibly difficult to deal with when we tried to print them out and read from them. And so the solution was that we modified the CSV file by removing commas in sections that aren't the genre, rating, or title of the movie so that it's easier to deal with. The other problem was that we had developed the entire max heap, and then once we developed the max heap and tried implementing our algorithms with it, it ended up becoming incredibly inefficient. And this is because the max heap is a binary tree. So it's really inefficient to iterate through with only two edges when you're trying to implement Kruskal's or Dijkstra's algorithm. And so the solution was that we had to remove the max heap that we created and replaced it with a different data structure, which was a graph that was presented as a disjoint set, which allowed us to iterate through more edges. And the third problem was with the breadth first search iterator. We could not iterate on the disconnected graph that we put our data into, because then it wouldn't go through all the elements. And so what we did was we actually conducted the breadth first search, and at the end of the algorithm, we looped through an array of booleans called visited at the end. And so if something wasn't added during the iteration, it'll show as false in the visited array, and then we would add it to the queue.
Okay, so basically we have these two images that are graphical visual representations of our graph. One consists of 100 movies and one consists of 10 movies. And so we had three output image lists for our graph. So this one was, say, like we wanted like a sample of 100 movies. And so this would be the output, the initial output of just all the movies, randomized, no real order to anything. And then we had the spec data output, which is basically like the user chooses one movie they like, and then it basically like lists out a bunch of recommended movies that the algorithm would think they like based on the starting movie. And then we have this cat data output, which basically shows all the movies, but categorized into their own genres. So, completely ordered based on their genre.
One important lesson I learned from this project is not only is it important to understand the fundamental concepts of how specific algorithms work, such as BFS or Kruskal's, but also how important it is to understand how those algorithms could connect or not necessarily be compatible with each other when trying to achieve a specific project goal. And this was especially prevalent as we had to drop the max heap data structure in the middle of our project and substitute it with a complete alternative, which was a disjoint set. And so it's important to, before you start a project, lay out a list of algorithms that you believe you want to use and test and really understand whether or not they would work together. And for next time, I would hope to find a data set of metadata which has both reviews by critics and reviews by audiences, such as on Rotten Tomatoes, and try to arrange and compare those two data sets together and see how people choose those data sets and how it's distinguished between them.
I think it's really cool that like we have so much power at our hands with coding, and there's so much data available online that you can do so many things with, and it has so many cool uses. And I really think that my favorite part of the project was just like dealing with different data structures and seeing like what did or didn't work with certain algorithms, like such as our max heap thing, because considering they only had each node only really had two edges, it was harder to like run like Dijkstra's and Kruskal's and a bunch of other algorithms on it. I think it was cool that we like, okay, we're breaking down max heap, we're going with graph, and it ended up working really well. And if I think another thing I would really like to do is maybe go through Wikipedia hyperlinks. and see like how fast, or like maybe use Jigstras to like find the shortest path between one Wikipedia page and another Wikipedia page based on the hyperlinks available on the starting one and the path moving forward. Because I think that would be a really cool one.
So as for me, I really enjoyed working with like different algorithms that I made, and like working with how they were applied in real life. So whenever I searched for an algorithm, I was able to learn more about how they were applied in real world scenarios, and like how they, to figure out how they would be applied for my purposes. But in turn, it also taught me how it would be like useful in other scenarios. Like, yeah. And essentially, I also figured out how to work with graphs and essentially integrate two different things that were different, like that were vastly different, like disjoint sets and a graph, to make it work harmoniously together. Now, as for what I would do better next time, I would try and figure out a better way to implement our graph system, because right now our graph system is kind of slow to initialize, but all the algorithms on it work just fine. It's kind of slow to initialize the initial graph. And I would try and work on figuring out a better way of initializing the graph. Thank you.